today let us discuss on the topic of defuzzification. So defuzzification is a mapping process from a space of fuzzy control actions defined over an output universe of discourse into a space of RISC, that is non-fuzzy control action. In a simplified way, we can specify that defuzzification is a fuzzy to crisp conversion. So we have some of the defuzzification methods. So we have 4 methods of defuzzification. The first one is the lambda cut method, weighted average method, maxima method, and the centroid method. So in defuzzification, let us discuss on lambda cut method for fuzzy set. In this method, a fuzzy set A is transformed into a crisp set A lambda for a given value of lambda where the lambda lies between 0 to 1. That is, it should be less than or equal to 0 and so it should be greater than or equal to 0 and less than or equal to 1. In other words, A lambda is equal to set of x where the membership function of that x should be greater than or equal to lambda. That is, the value of lambda cut set A lambda is x when the membership value corresponding to x is greater than or equal to the specified lambda. This lambda cut set A lambda is also called as alpha cut set. So let us have a problem here. So we have two fuzzy sets A and B which is defined on x as follows. So here the values A and B and the membership function of the values of x1, x2, x3, x4, x5 is given as 0.1, 0.2, 0.7, 0.5 and 0.4, and for the set B will be having 0.9, 0.6, 0.3, 0.2 and 0.8. So the thing is we have to find A 0.2, B 0.3, A union 0.6, A union A 0.8, A intersection B 0.4 and A complement of 0.2. Okay. So the solution is A lambda, what it should be? The membership function of lambda value should be greater than or equal to. So here what we have is A 0.2. So A 0.2 means, so what we should have? So the A set we should have, and the lambda value here it is given as 0.2. So we have to find the values in the A set which is greater than or equal to 0.2. So what are the values we'll be having? See here, for x1 it is 0.1, so we don't have this, and for x2 it is greater than or equal to we are having, so we can choose this x2, and 0.7 it is greater than or equal to lambda value, 0.5 greater than or equal to lambda value, as well as 0.4 is greater than or equal to lambda value. So the values we'll be having here is, we'll be having which will be equal to, so what are the values here? X2, X3, X4 as well as X5. So X2, X3, X4 and X5. So this is A.02. Okay. So the next one is we'll be having B of 0.3. So if it is of B 0.3 means what is the formula? We'll be having the lambda value should be greater than or equal to your membership function value. So here we are having it as B. So B means, so we have to see the set B. So in B set it should be greater than or equal to 0.3. So what are the values we'll be having? X1, X2, X3 as well as X5. Okay. So here we'll be writing it as B03 which will be equal to X1, X2, X3 and X5. Okay, so the next one is A union B. So if it is of A union B means what we should have? We should get the maximum value between the A value and B value. The membership function should be the maximum value. So we already know if we have it of A union B means we have to find the maximum of the set A and B. So this is the formula we have. So here A union B 0.6 we are having. So 0.6 means first what we should do, in A and B we have to take the maximum value. So what are the maximum values we will be having? 0.9 here we are having, and in this set we are having 0.6, and here we are having 0.7, here we are having 0.5, and x5 we are having 0.8. Okay. So what we have to write here? First we'll be writing here A union B. So A union B will be of, so we'll be having 0.9 for x1, 0.6 for x2, 0.7 for x3 and 0.5 for x4 as well as 0.8 for x5. Okay. So we have got the values here. See here the maximum value. So maximum value is 0.9, 0.6, 0.7, 0.5 and 0.8. So that's what we have written here. Okay. So now what is our lambda value? A union B 0.6. So the lambda value is 0.6. So what we'll be having? A union B 0.6, which will be equal to, so this x value should be greater than or equal to 0.6. So 0.9 is greater than, so we'll be taking it as x1. 0.6 is greater than or equal to, so we'll be taking it as x2. And for x3, 0.7, here 0.5. So here we are having 0.6, so it is less than, so we'll not be taking it. And 0.8, so it is a greater value, so we'll be using this x5. Okay, the next one is your A union A 0.8. So A union A means what happens? A union A means again the same set we'll be having. So the same set means the values will be 0.1, 0.2, 0.7, 0.5 and 0.4. So here what you are having? A union A 0.8. So 0.8 means we have to find the greater value 0.8. Okay, greater than or equal to 0.8. So what is the value here? We are having 1, 0.1, 0.2, 0.7, 0.5, 0.4. So no values are greater than or equal to 0.8 here. So just will be having an empty set. So this will be an empty set. Okay. The next thing is your A intersection B 0.4. Okay. So A intersection B means what you should have. If it is of A intersection B means we have to find the minimum value. So minimum value between A and B we should have. So what is the minimum value? The set we are having is, what are the sets we are having? See here, 0.1, 0.9. So among these two the minimum value is 0.1. So among these two the minimum value is 0.2. Here it is 0.3 and here it is 0.2 and here it is 0.4. Okay. So let us write it. So let us have the values here. See here. So A intersection B will be the minimum value. So 0.1 for x1, 0.2 for x2, 0.3 for x3, 0.2 for x4 and 0.4 for x5. So this is the minimum value. So what happens here? We are having A intersection B 0.4. So A intersection B 0.4 means what you should have? Here 0.4. So 0.4 means the greater than or equal to 0.4 you should have. See here 0.1, 0.2, 0.3, 0.2, 0.4. So what happens here? We'll be having only 0.4. Okay. So the A intersection B 0.4 will be of x5 alone. Okay. So this is how we have to find. Thank you.